So we have given here the function as 3x squared minus 4x plus 2, but our goal is to find the function at a plus h. So let's try to do that. So by this question, you know that we need to figure out f of a plus h, right? And how can we do that? We know that all of the evaluation of the function can be done by replacing x completely by wherever we need to evaluate. So in this case, we need to evaluate at a plus h. So this x over here we replace by a plus h. Over here there is another x, we also replace that by a plus h. And so let's try to see what will happen after that. Okay, so let's begin from the first term. Then we have 3x squared. So if that is the case, let's write down 3 as it is. And since we have here x squared, replace that x completely by a plus h. But when we do that, replacing x by a plus h, since we have x squared, then on that case we'll have square of a plus h, right? So same thing we do on the second term. We have negative 4 times x. So if that is the case, we will write down negative 4 as it is. Now we replace x completely by a plus h. And then on the last term we have positive 2, so we just write that down as it is. There is no x, so we just leave that as it is, right? Okay, so that is the value of the function at a plus h. We are done. But sometime we need the expansion of this. So if that is the case, we need to know how to find the expansion. Okay, so to do this one, first let's try to expand this square of a plus h. We try to see what does that mean. Okay, so let's try to see what is a square of a plus h mean. How can we find that? We just need to multiply a plus h with a plus h, right? So that's what I mean square of a plus h. So if that is the case, we have the binomial term, so we can just use the FOIL method, so which is multiply the first term with the first term, we get a square, multiply the outside term, so we get a times h will be ah, multiply the inside term, then we get a times h is a times h, right? And then s times h will be h squared. So we have that one over there. Okay, so can we combine something? Oh yeah, right? What can we combine? Well, ah plus ah, so that will be 2 times ah, right? So we can do that. So if that is the case, let's try to do that. But there is no other a square term, so we'll leave that as it is. A times h plus a times h will be, when we combine, we get 2 times a times h plus, and then again we don't have any other h square term, so we have that. So this is the expansion of a, if you have a plus h, sorry, square of a plus h, this is the expansion, right? And then we need that over here to write it down. So we have 3 on the first term, multiply by square of a plus h, so we can just plug this information in over here, which is a square plus 2ah plus h squared. That is the expansion of square of a plus h. And then let's write down the second and last term as it is. So, and then now let's try to do one of the other thing, that is we can distribute by 3. So 3 times a square will be 3a square, right? And then we have 3 times 2ah, so this will be, then 3 times 2 is 6, so we have 6 times a times h, right? And what is 3 times h square? Well, 3h square, right? Okay, so let's write that down. And in the same way, you can see here negative 4 times a will be negative 4a, and then negative 4 times h will be a negative 4h. And then we just have the last term here, positive 2, so let's just write that down as it is. We are done even with the expansion, but if we see there are some like term, we could combine. So let's try to see if we have that. So this is 3a squared. Do you see any a square term? No. This is 6ah. Do you see any a times h term? No. No 3h is in the h square term, no a term, no h term, constant. So okay, all of these are unlike terms. So if that is the case, this is the nice expansion, right? Or what we can say right now is this is the value of the function, the given function at a plus h, and that's how we can find it.